The first definition we are going to learn is we are going to revisit the notion of congruence, but not for integers, for rings together with a fixed ideal. So suppose we have a ring R and I is an ideal of R. We say, I guess one thing first, for AB, for two elements of R, we say A is congruent to B modulo I if B minus A is in I. In this case, we write A plus I is B plus I. And I will explain this notation in one of the later videos. Sorry, this is a B, not a 6. I'll explain this notation in one of the later videos when we talk about and introduce coset. For now, let me give you an example. In fact, so I'm going to give you an example, and then we'll do some more examples in the next couple of videos. So suppose for a moment that R is Z, and I is the principal ideal generated by some M. Then what? Well, suppose that we have two integers, and they are congruent modulo the ideal M, the ideal generated by M. This means then that B minus A is in the principal ideal generated by M. But what does it mean to be in this ideal? It means you're a multiple of M. So B minus A is MK for some K and Z. So what does this mean? Well, A is congruent to B modulo the number M. So we've seen here that if you're congruent modulo the principal ideal generated by M, that tells you you're actually congruent modulo the integer M. And actually, the converse is true. Namely, if A is congruent to B mod M, then we're just going to run this argument in reverse. B minus A is a multiple of M. Well, what does it mean that we're a multiple of M? It means that we're in the ideal generated by M. So A is congruent to B modulo the ideal generated by M. Or with our notation, A plus M is B plus M. So what this example is saying is that this notion of congruence modulo an ideal recovers the, let me say it like this, congruence modulo, this tells us then that congruence modulo the principal ideal generated by M recovers the usual congruence mod M. But now we have a version that works in any ring with any ideal. And we're going to explore this throughout this section.